It's no secret that I'm not a huge fan of dirac, but they seem to have hit the jackpot with their recent art release. The bass management is superior to what any classical method can achieve, and while the rest of the calibration is standard dirac pliable, as we all know, well-sorted bass helps the rest of the system open up significantly. They are using a technology called MIMO, multiple input, multiple output. While it literally means using multiple antennas to transmit and receive signals simultaneously, it's actually not a new technology. The first hardware implementation was developed by a French aerospace lab, Onera, in 1974, using a circle of antennas to send encoded signals. However, the term MIMO wasn't coined until a 2003 MIT Lincoln Lab paper, which proved that using multiple waveforms could drastically increase radar resolution. In radar, each antenna transmits a unique waveform. When these bounce back, the processor combines them to create a virtual array. A physical radar with just 3 transmitters and 4 receivers can act like it has 12 antennas. This is how self-driving cars today can distinguish a pedestrian from a parked car without needing a giant dish on their roof. If we come back to the audio implementation, this is where the radar comparison gets real. Many people mistake dirac art for a modern double bass array or simple reflection cancellation, but it's more complex. Just as MIMO allows a small radar chip to act like a massive dish, it allows art to effectively push the acoustic boundaries upwards, making a 3 meter by 4 meter room sound like a 12 meter by 12 meter space. It looks at every transfer function in the group and solves a massive matrix of equations using constructive and destructive interference to actively control the pressure field, treating your random layout of speakers as a single unified phase array. In practical terms, it looks at how every speaker interacts with the room and uses them to support one another and says, if speaker A creates a resonance peak at 50 Hz, speaker B and C should emit a specific phase-shifted signal to flatten that peak instantly. As an audiophile, if you've ever had the opportunity to listen to a decent sound system in a very large room, free of early wall reflections, I guess this is the closest experience to understand what art is doing. You may know MIMO from Wi-Fi, the multi-antenna spider routers. While the idea is related, dirac's implementation is actually closer to radar. For example, in audio calibration, a measurement sweep is called a chirp, not because it sounds like a bird call, but because it's short for compressed high-intensity radar pulse, describing a pulse that sweeps from low to high frequencies. As you might guess, I had to learn far more about radar systems than I ever did during my aerospace engineering bachelor's just to figure out how to implement this using the available interface. Did I succeed? Well, let's dive in and you be the judge. This new version, Evo AcoustiX, as the name suggests, is a mixture of Acoustica and Express, builds on everything the previous tools did well, but with a cleaner workflow, smarter algorithms, and if you wanted, more customization than anything else that's ever existed in home audio calibration space. It's still completely free, and the focus is still the same, practical results, and making better sound accessible to everyone. You have to download the tool from the link that will be given in the video description, which will take you here. And you have to download a version that's suitable for your operating system. There's a version for every operating system, and I'm on Windows, so I'm going to download the Windows version. This is Mac OS for M4 Max, and this is Intel Max. Let me download it here. You have to remember the folder that you downloaded it to, and you can move it between folders because it doesn't install. It just works on the go, so it's portable. And unzip the file, and that's it. You have the file now, program. There's the Evo AcoustiX tool, which is this executable file, and it starts by double-clicking it, and then there is a target curves folder and TR curves folder, transducer, bass shaker curves. Let's double-click it. You can run anyway, this one, or better, right-click, go to Properties, Unblock, OK. Every exe file that's downloaded from internet, Windows will do that. Now it will open right away. And this is the tool. You need to install REW Beta 109 or higher. There's a link here which will open this page for you where you can download REW, which is also a free tool for your operating system, including Windows, Mac, and Linux. Let's do that together as well. So it goes to download folder. REW is already installed in my computer, but just double click the exe file like you do with AcoustiX. REW installation doesn't take too long. Yes, accept 4 gigabytes, please. Next. Here, don't use hardware graphics acceleration if you have an ancient computer with no graphics card. onboard or whatnot, because then it slows REW even more. And that's it. It will install within seconds. If you have a lower version of REW, it will warn you and it will not start. Higher versions are okay, and we can even run it. Actually, let me not run it now so you can see that it can run REW on its own. So here's our program. I strongly suggest for Windows users to download Windows Terminal, which is a free tool. It's usually already embedded in Windows, but mine didn't have it for some reason, so that you can see the symbols properly. Otherwise, you will see ugly question marks and stuff here, and the fonts will shift to other fonts and they will change sizes from run to run. Terminal doesn't have any of the problems, it's decent. Now, REW Room EQ Wizard installation step is complete. Second step is set up audio video receiver. You have to do this from your receivers menu and using remote control. Do not use web UI like I will do just now. I do this only for illustration purposes. It does very weird things that you don't want to risk. Okay, amp assign and speaker config under speakers menu. These are the two settings that should be correct, and the full optimization, calibration and whatnot will be all dependent on this configuration. And you only change this configuration when you add a new subwoofer or a bus shaker, or change your speakers and ceiling speaker format and what have you. Otherwise, don't touch it. But at the very beginning, make sure that it's correct. Here, for example, mine is at 11.1 channel format. This is the only way to use external amplifier in my model. And my pre-outs are connected to fronts, but like one of the bugs in web UI, no matter how many times you select front, it will switch back to rear height. As you know, rear height is very common externally amplified speaker set. So I think that's why they are defaulting for it. So if you do this change from your amplifier with the remote, it will happen right away. Things like that, like full of bugs, so don't rely on it. And what height speakers do you have, what is their name, and what's the layout? For example, I don't have surround backs, but this is the only way that you can use the pre-outs in this model again. So this should all be correct. And in speaker configuration, my surround backs are none, because I don't have them. And center is none, because I don't have it. So not only amp assign, but also this configuration should be correct. Subwoofer numbers, what speakers you have, and what you don't have. Large, small doesn't matter here. Keep them all at small, because some models have bugs if they're large and AcoustiX tries to change them back to small during transfer, they collapse. We fixed that with Herr George Rao last night, but you never know what new bugs Denon and Marantz will throw at us. And if you have a bus shaker, and if you have an old model like mine with only 2 subwoofers, you select here 2 subwoofers, not 1. So bus shaker is a subwoofer, by all means, in AcoustiX. If you have new model and 3 subwoofers and 1 bus shaker is always supposed to be SW4, and then you have 4 subs, and SW1, 2, 3 are your subwoofers. That's important. And that's basically all the change you ever have to do in your receiver, and only once. Make sure this is correct. Now back to the tool. We completed setup step. Prepare all speakers, check them for correct wiring, polarity, positioning, and toe-in angles. The speakers should be facing main listening position properly. That's called toe-in. And position them for their permanent location before you take a measurement. And correct wiring is very important. Let me, like 3 out of 10 systems that I see, because I regularly get M.dot files from users, like 20 a day, 3 out of 10 have at least 1 pair of speakers with wrong polarity, okay? And external amplifiers also tend to switch polarities, but it's worse than that in general. So double check them. AcoustiX will warn you for polarity, but it's not 100% reliable, but it will at least give you a reminder. And if you get wrong polarity warnings and you're sure that your polarities are correct, you can simply ignore the message. But it points to something weird about your speakers. That's another story. Prepare subwoofers. Disable all internal processing in your subwoofers, be it LPF or some special filters or its own room EQ and whatever, corner mode, this mode, that mode. These are all delay introducing unnecessary circuits. Just make it as plain as it's possible in its default setting so that it fires fast. the rest of the settings will be done by AcoustiX. And switch the power before measurement to always on rather than automatically turning on, like auto on, because auto on doesn't trigger as quick as necessary for measurements, especially if it's the first time you're measuring your sub. You will miss 3 out of the first 10 chirps. Definitely, you will only have 7 chirps. The measurement will go through, but we are all obsessive compulsive, so why miss the 3 chirps? Decrease the signal to noise ratio. And max out its LPF settings or connect it directly to LFE if it has a separate input for that. Prepare your room, minimize noise, turn off air condition, fans, and close doors and windows. And connect your microphone that came with your audio-video receiver. Plug it to the calibration mic jack in front of the AVR. This is from before measurements and all the preparations you need. And then, this is the menu now. If you don't have a configuration file yet, okay, this is a clever menu. If you have a configuration file already in that folder, it will know about it. If you have a measurement file in that folder, it will know about it. And if you have a calibration file, which is an optimized measurement that goes to the receiver, it will also know it. So here you have 2 options. The first one is express calibration. This is all automated. It takes, you have to place your microphone in at the main listening position at ear height, directing straight up, and it will start taking measurements of all your speakers and subs individually, and then start to optimize it without any questions or any options requested from you, and then start transferring the file to your receiver. And within 3-5 minutes, I mean excluding measurements within 2 minutes, but with measurements depending on the number of repeats you select, you will be done within 10 minutes, and it will be quite a different calibration if you have never used A1 before. But with AcoustiX we also introduce measure system at multiple mic positions. That is not only a single mic position, but you can measure wherever you want in the listening area. The first measurement should be at MLP, central listening position, and the rest you're free, and you're free to experiment with it, but my suggestion would be about 50 centimeters around the MLP, as many microphone positions as you want. But there is a very smart measurement averaging algorithm at the moment, which took me the longest time to write in AcoustiX, and I think you can freely move larger distances. Like if you have rows of seats, for example, maybe you can take 1 measurement at every seat. These are for you to experiment. The results are very quickly uploaded to your receiver. That's the advantage, so you can keep trying for the best results. Let me go through this, but it will only get error. Look, it already found my AVR in the network. Okay, here make sure your VPN or firewalls, whatnot, is turned off. It 99% of the time finds your AV receiver in the network. If it doesn't, it's something to do with your network. It could be your router having some extra security settings. VPN, almost always, if you don't know how to set up VPN properly, almost always gonna block this. By the way, I don't know, but network experts have VPNs and they can also find their AVRs, not me. And it tells you the model, and it already read the speaker setup. At the moment, because of taking quick measurements all the time, I changed the setup of the receiver. I have more speakers than that, but you can imagine testing this tool, just 1 round of measurements takes quite a bit of time, so I decreased the number. And please confirm if these are correct. If it's correct, it's yes, continue. And here it's asking you how many repeat measurements you want at MLP for each speaker. You can take up to 99 repeats for every single mic, every single speaker and sub. That's gonna take like a month to finish, but I mean, I would say 3 is a minimum, but 6 to 9 is gonna end up in quite reliable measurements of your system, and it's important. And don't hesitate to repeat measurement process more than once, because there is a bass frequency wobble in these receivers, which nobody could explain to this day, but I have tested it with very sensitive, very high quality microphones, and it's sometimes not there. That's why we don't even understand why it's happening. So sometimes measurements are very clean, but sometimes at 50 Hertz, 125 Hertz, 425 Hertz, there are wobbles. And it's not AC line, because guys in US have the same frequency wobbles. They don't have it at 60 Hertz. So it's, and sometimes it's AC line also. It's quite common. So repeating measurements, even like taking measurements late at night when the electricity is cleaner, can make a difference. So don't think that I measured my system, now I just have to optimize it better and better. Believe me, repeating measurements and using the same settings most likely will result in a better calibration if you are into that kind of sophistication. Let's say 1, okay, also this is important, always start with 1 first. This is to test your setup if everything is working, because if you like start 20 repeats and then you figure out that your rear height speakers are silent and it will just stop with an error, you will curse at me. So better start with 1. If everything works with 1 or fails, fix everything, then go and start your repeat measurements. So let's start with 1. Critical error, calibration microphone was not detected. Okay, I will go and plug in the calibration microphone just for the video. All right, done. As you see, it doesn't error out. You just press enter and the menu comes back. So it's a lot more user-friendly compared to Express. Now again, 1 repeat and going through. It's checking, headphones not connected, mic is plugged, and stabilizing the AVR. For example, this weight, my model doesn't need this, but there are models without this extra weight here, they crash. So it's okay, now my external amp is not turned on, so it's silent sweep and it's gonna throw an error. That's why now I go and turn on my external amplifier and restart everything. Another wait of 15 seconds. Look, my relay clicked already, so my model is in fact ready. And I can read that with the code, but some models, if you try to read it during this period, they crash. You are hearing 10 chirps from each speaker now. And because my subwoofer is an auto mode, you will hear only 7 for the sub. Now listen to the sub chirps. Okay, this second louder trial is because of the noise that I made. The AV receiver automatically does that. See? It was only 7 chirps. Now it's 10, because it only just turned on. And that's all. I took 1 repeat set of measurements on my complete system. And it says that REW is installed, but it's not launched, so it can launch it itself. Just click yes. Also done. Here it's already making a reversion control, and it will warn you if it's not. And look, the optimization started. These are our measurements, and the tool is already generating. It's at the final stages already, creating filters and finished. It created 1 OCA file, this is the calibration file, and 1 HTML file, which is the log. A copy of this log, okay, is kept for your future reference. And when you click here, everything shows up in REW, like that. Let me fit the data and right-click, clear selections, and swipe them all the way down. Remove this one because it's the original subwoofer. And here's the calibrated system. This is my front right speaker, front left speaker after calibration, surround left, TFL final, SRA final, and TFR. As you see, with 1 repeat, the results are not really that good looking, but this is still sound quite good. That I can assure. It's all about timing and whatnot. Let me explain a little bit about if there is anything an uninterested user needs to know here. Here it gives you a very accurate, the results. I know why they are bad, because the microphone was on the floor. Yeah, that's how I'm just about 11 centimeters off from center. So when this is yellow, it means your microphone MLP position was not really central between the front left and front right. Normally this should be green. And what else? These 2 numbers, this is it's decided my subwoofer starts from 48 Hertz, rolling down in bass and goes up to 228. This is quite correct. It's 42 to 225, my miserable focal sub air. And the crossovers that it came up with for every speaker, which is correctly found from the room response, but not when the microphone is on the floor. My surrounds are actually focal dome flux, and they should be about 120 Hertz. And the distances, which is relative and doesn't really mean my subwoofer is 8 meters 41 centimeters away from MLP. It's actually nearby front speakers, but this is how it works. Subwoofer signals, bass signals, arrive later than everything else. They have longer wavelengths and they need to be fired first, a lot earlier than, in fact, if my receiver allowed it, it would be even sound better in longer distances here. The longer the distance, the earlier that speaker or sub will fire. So here in my system, front left is gonna fire last. It's the closest to MLP because the microphone is on the floor, very close to it. So my system is not really that asymmetric. This is just a trial run for illustration purposes. Anything else you need to know here? Okay, it says please go back to the terminal window to transfer the saved calibration file with OCA extension to your receiver. And the whole optimization was completed in 42 seconds. And as you see, here is your calibration file. Here is your log, the full log of this optimization run, with its time and date stamped on the names, as you see, December 2. And recently there is also it's saving the measurements here in this file early before the optimization starts, and it's also now saving the results, all with time and date stamps, so you cannot really get confused. So anytime in the future you can look and check any of these for reference. And this is the measurement file that we just took. That's basically it. And there is a terminal window, which it was also reminding us the same thing here. Complete the optimization in your browser here and ensure the OCA file is saved. When done, press enter to transfer, press enter, and as you see, transfer starts. It already said LFE and 120 Hertz. It says calibration microphone is currently plugged into your AVR, because some users reported in some models when the calibration microphone is plugged in, the transfer doesn't go through correctly, which is not the case with mine, but there is a warning, and I'm not gonna unplug the mic, and I'll just press enter to continue. And as you see, the same channels and one by one are going to flat and reference mode, which will result in this response at the end. And here, by default in Express workflow, flat is the mode that the AVR will be set at the end of optimization transfer, and it's the mode you should listen to your system. And in reference, there is low volume level filters, which is for night listening, and it has higher bass and higher high frequencies. Some bass freaks out there prefer low volume filters, even in normal listening volumes, which is okay, but it has significantly higher bass by default. In custom, you can adjust this too, and higher high frequency output, which makes things more audible when the volume is very low. It is adjusted to about -20 dB lower volume setting, and it uses dynamic volumes on graphs for 20 dB volume difference. But where this volume difference is also matters. So it doesn't mean if you're listening at 85 normally, you have to definitely listen at 65. You can decide this with your ear. If you don't like it, if you think it needs more bass, less bass, whatnot, go to custom and customize it. So how you will go to custom? As you see, the menu now already items are highlighted because now there is a measurement file, which means it can use these measurement file and go to customization. But before that, let's go through measure system with multiple mic positions, the new addition to AcoustiX. No, this is standard. Measure system. So here now the new menu. Ensure the calibration microphone jack is securely plugged into the front panel. The first mic position must be at primary central listening seat and will determine speaker distances. Important. Microphone tip should be seated at ear height and pointing straight up at the ceiling. You can measure up to 20 different microphone positions. You will understand that I will go with like 3 or something for the demo. And at each position, you have up to 9 repetitions for the same sweep to eliminate noise and improve signal to noise ratio of the measurements. Let's say 5. I'm going through measurement process already. So now here you can just press enter and start measuring, or if you want add some time pause before the sweep starts so you can leave the room every time. I don't need to. And the classical wait screen. Now the repeat is coming. Listen to me, this is indicative. This is reported by the AVR. That setting is not used anywhere in the optimization. It's just during measurement to give you an idea if your mic is central or not. When the measurement is completed, it will give you a report much more accurate than that. 505, lots of noise in the house, and now let me explain this part a little. So it's choosing from 5 measurements which ones to average. It's ditching the bad ones, but here by using averaging and the cleanest ones, it increased simultaneous ratio of the measurement from 39.19 dB to 40.48 dB. And it selected measurement repeat 3 as reference because it gave the highest SNR average. And it uses 2 different methods for this, and it selected method 1. It always selects the highest SNR method and the reference, and eliminates if some of them are not useful at all. It does that for every single speaker with Cirrus Logic DSP models. Unfortunately, you can only get report at the very end when every speaker completes. So similar for FR. Okay, this is accurate now. There is 109 millimeter difference. It's off center, closer to front left speaker, it says. So when you see this, for example, you should restart your measurements. You didn't place the microphone properly. And also a polarity warning. So far, they all seem correct. If it says incorrect, inverted polarity, you have to double check your speaker polarities and triple check, because some people insist they checked and it was fine, but I see their MDOT files and it's inverted. And they complain in forums that Acoustica and Express was finding their speakers inverted, and then I show them in their MDOT that they really are inverted, but they never go back to the forum and admit that, yeah, mine was inverted. But this is like, okay, we are not gonna wait for all this, we're gonna lock the amplifier What happened? Oops. Yeah, Ctrl-C completely kills. Okay, this didn't end well. Now, once you have your measurements, as many as you want, multiple mic position, single mic position, you can see in the file name what it was. This is like the first one repeat. If this could be saved, it will be 5 positions, 5 repeats. Okay, and you can optimize any of these measurements with default settings, just like Express does in the Express workflow, or you can transfer any calibration file that is optimized with this one in the menu, or the new edition, you can go to custom settings. Now let's try custom. We will have to use this one repeat one, and this is the new customization menu, but let's not use this horrible one. And proper 3 position, 3 microphone position, 3 repeats one of my test measurements for my system, but I hope that it was for the restricted speaker. Anyway, now you can choose from 3 position, 3 repeats, and here you go. Now here you can start optimization, and it will go with default settings. It is gonna delete everything in REW, but you can do it yourself. Here you can set your crossover frequency search ranges. First, let's do the normal one and change your target curves from any of those, or your custom target curves, which you have to place here under target curves, okay? But make sure they are proper target curves, as in, let's try one of curves, for example, as in the 1000 Hertz should be at 0 dB, okay? And it should go well into 3 Hertz here and about 24,000 Hertz here. No more, no less, okay? Don't put something with some slope here, things like that. This side should be flat, and it should go to 6 Hertz. These are the conditions. So that's that. And similarly for bass shakers, these are the bass shaker curves I could find. Let me show you these actually. Bass shaker curves are more like, as you see, this is Chris Pop curve. The bass rise starts around 200 Hertz, but bass shakers only rise off below 20 Hertz. And that's one reason I didn't let this be done in REW EQ because REW EQ ends at 10 Hz. So you can still create your bus curves, but the same logic, make them go even lower, as low as possible, because look at, they are still there at 2 Hz, because this is how bus shakers work, and anything beyond, I would say, 50 Hz in any of these curves, okay? And whatever you put here, in whatever the name, will show up here, and if you have a bus shaker, also here in this menu, and you can select them from here. And you will also see a graph of them here, which is going to be correct. Second customization is your crossover search range. Is my lock still here? Yeah. For example, this one, it found SLA and SRA 80 Hz, but I want them at 120. I believe my speakers will sound better at 120. I wrongly believe, of course, but it's your system and your customization. So what you do is just surround speakers, start from minimum 120. And if you want them to definitely only end up at this, for example, this is going to search them between 120 and 200 and decide which frequency is the best. But you can just do that and surround speakers right now. All of your surround left, right, and surround back, left and right, will end up at 120 Hz crossover and will be filtered accordingly. So this is not the same thing as changing it afterwards in the receiver. And same goes with Atmos height and center and front speakers. So let's do that. Let's make them 120. By the way, because now I have proper measurements in, even standard optimization should find them better than 60 and 80 Hz. Yeah, see 100, 100, 120, 120, and 40, 40 because I have large front speakers, counter tools. And volume alignment is done a lot more accurately than 0.5 dB, that's the AVR limit, because it uses filters with a trick to do these adjustments for every speaker, which nothing else in the market does. And finished, 32 seconds, because it didn't search as much. Look, with better measurements now, it's 41 Hz, my subwoofer roll-offs, and 211, a lot closer to actual spec of this subwoofer. And I don't think, I mean, spec says 40 in Focal website for my sub, and I'm pretty certain that not every subwoofer from factory comes out at exactly 40, and 41 for mine is quite decent. And with custom though, you don't even need to check these are correct or not, but it does a decent job. This is only used for leveling subwoofer volume. Okay, I can't tell this enough times. It doesn't apply high pass or low pass filters at these frequencies. The subwoofer already has a high pass filter at 41 Hz. Why would it apply it again? And this is the result. FR final, as you see, much better than before. And subwoofer, this is normally you should clear selections and do this every time to see what your system is going to sound like. These are the filters here, and FR final and TFR final and SLA final. And here's another thing, when you have this screen here, well, that changed my mind. And now let's keep trying. I have to show you all the customizations, I guess, this video. So go back, optimize measure system, 3 position, 3 repeat. And what else you can do? Interactive volume leveling mode. Start optimization. Deleting everything in REW and start it on. And as you see, because my screen is very limited at the moment, this is what you see. But maybe I can do this. Now you have your speakers already volume aligned for this target. Okay, the target level is taken from front left speaker, and every other speaker is aligned to that with ISO 226. This is the most accurate alignment in the market at the moment. Anyone telling you that the alignment is not well, I mean, like I wrote all this, but I don't know that the target should be a little higher, or ISO didn't know. Don't really listen to all the rumors, I would say. And you can see it moving on rev screen. It moves with a little bit of delay, that was necessary for all the API to work in the background. But if you are this expert who knows their targets better than everyone else in the world, here you can change your target curve. And on top of that, once you align target curve on your speaker responses as you wish, then let's do this. You can also, this is what Acoustica decided your subwoofer should be, and your target curve level, what it should have been. Now I moved it. But if you're not happy with it, you can also align subwoofer level on that target. So basically here, given your speaker responses, let's put FL and FR here, okay? Or let's put just FL. you can adapt your subwoofer to your speakers the way you want. If you press cancel, every single moment here will revert, so no worries there. It was quite tough coding. And confirm, and you get all these reports here. Target now is 74.20, time aligning, blah blah blah. Custom user applied volume offset 2.7 dB, final applied subwoofer volume 6.3 dB, and distances will change a little depending on subwoofer volume level, and finished. And now you have your expert result. Okay, this dip is not audible at all, so it's not like, let me explain this dip thing for people who really want to learn these things rather than look like they already know these things. For example, psychoacoustic smoothing, when you apply to that, you will see that it's going to be under the target curve. See, there are gaps. The reason for these gaps is those dips. You see, for example, here it was over the target curve, here it was over the target curve, here it was already over the target curve, and here. But when you switch to psychoacoustic smoothing, which will exactly show what you will hear, it didn't show you level bass here by the target, and then a dip here, and then another level by the target. Instead, it just decreased the overall bass level half a dB, because that's what a dip does. It doesn't hide from you all of the 60 Hertz bass response. Instead, you hear slightly less bass overall, okay? So the dips are not as big a problem as you think they are. And if you just select a slightly higher bass slope target curve, you will hear the same thing as completely flat response at this target level. I can show you with this, everything at the same level. Let's say 74.2, I should remember that, 74.2, and let's do dirac and audyssey style, no shelves. Shelves are cheating. To 32 to 85. Match response to target. Wait, if you don't add overall max boost, audyssey style, it's not gonna work. Look, I did the best calibration ever. It has no dips. Generate measurement from pre. Now, as you see, the dip is gone. And look at the cycle. The only difference is this one is right on the target. Whole screen. So that's what a dip does, more not less. By the way, the blue one will sound awful. Major distortion and ringing in the bass, raining over all the mids and highs. It's not gonna even be close in clarity to the other one. So that's that. Now, remove all and let's continue showing customizations. Don't keep too many of these open. When they are finished, it's fine, but if you just halfway stop them or something, because I know many of you do, and if you open a new one, you can lock REW forever, meaning you can only end it from Task Manager and then you have to restart. And one more run is our, this is open. See, I can use the same menu over and over, optimize a million times. So what did we try? Not try. There's double bass LFE option, and you can change your bass extraction frequency. There are explanations here, tooltips for every one of these settings, as you can see, including crossover, I think. Okay, so bass extraction frequency is front speakers will play all frequencies, subwoofers will contribute up to that frequency. This is what double bass is, okay? And MIMO processing uses that trick for everything, which I will explain later. Here, EQ filter maximum gain up to 6 dB. You didn't even need this, by the way, because I will show you later what you can do with this customization, but it's here anyway. And when double bass LFE plus main mode is on, these are the only settings. You can change LFE, which should always be at 120 Hz, but in case you have some special purpose, you can change that. You can change this one just as well in the AVR. It's not going to affect the calibration. You can lock subwoofer polarity, so subwoofers are not going to be inverted or evaluated. Again, it's in the tooltips. And if you are not using double bass, as you see, double bass grays these out, but if you are using it normally, and fronts are always considered with subwoofer time alignment, but you can add into that center, which will improve your center speaker, but deteriorate your front speaker image. Because subwoofer can only be aligned to one speaker at a time, to be honest. If your speakers are the same distance to MLP, all of them, which is impossible to achieve, this may not deteriorate your general sound, but otherwise it always will. But you might have special reasons to include whatever you want in your subwoofer time alignment, and they will all go in. This is gonna throw in all the Atmos speakers This is going to throw in all the surrounds, this is going to throw in center, and you can do combinations of those. And if you start optimization that way, subwoofer distance will change, and it will consider both the surrounds and the front speakers to give the optimal sound pressure possible at a given subwoofer distance. Of course, within the limits of your AVR. The new models with dirac, that can do dirac actually, have 18-meter distance limits, which is finally enough, really. That's only just enough for very good subwoofer optimization. Unfortunately, our models have 6 meter, which I hacked to 7.35 meters. Enough for a lot of systems, but not enough for mine, for example. Let me show you quickly. Of course, when you don't have any measurements, what you do, you borrow this folder, right? Yeah, let's take the results. Okay, these are the speakers, and this is the sub. Now, this is what Acoustica can do within the limits. But as you see, my subwoofer, real bass signal, only comes here about 40 milliseconds into the future. And until then it wobbles. This is because it is using its port and the wall reflections and whatnot. It's a small sub. It's trying to accumulate first the strength and then fires up. But obviously the best sound with this one will be when this peak is here by the speakers. Okay, this is gonna be the fastest bass. Not necessarily the most frequency response rich one, but the best group delay and cleanest. But as you see, I still have like 9.6 more meters to achieve that, which my AVR doesn't have, but the new models have. Okay, but this is because of my sub. Okay, not all subs are that bad, but that's just to illustrate you. What else? So you can time align them, it will be automatically done. I don't think we need to show that. If I reload, yeah, I keep the curves, so good. Enable MIMO. Maybe it's time for it now. With MIMO, you have the upper limit up to 250. If you select 200 or 250, there will not be any additional EQ to front left and front right. But below that, it will have to do MIMO up to 120, and from 120 to 200 Hertz, it has to apply separate EQ to front left and right. Because MIMO filters do not let any other filter work on that speaker when they are active. So, but by the way, they sound in my system best at 120 or even more like 100. But let's try 200 for ease of use. And the EQ filter maximum gain is turned on to 5 dB in MIMO, but this is for every other speaker but not the fronts and the sub. Because sub and fronts are gone to MIMO processing, and because sub has an ugly individual response on its own after MIMO, the other speakers need some boost to fill the gaps, so that's why. But you can also remove it if you want. You can't align sub to anything else but fronts, and basically double bass is locked and enabled. It's not choice. This is the only way you can do MIMO filtering. So MIMO has these restrictions, and it has to use as many speakers as possible, and they should be out of phase with each other and different distances from each other to NLP. And they should be able to fire at the same time, which is not the case with our models, I mean through audyssey interface anyways. And the only time that our models are capable of playing two speakers, more than one speaker together, is LFE plus main mode, where they play subwoofer along with fronts. This is why MIMO can only be applied to these. Let's continue. Go MIMO 200, start optimization. Everything is cleaned, and so subwoofer 5.57 meters now all of a sudden. It's having to compromise here because it hits the limit and like the best of the bad alignments. And done. And with MIMO, again, do this and remove the sub. You will see that there is no FL and FR final. There is only front soundstage. Look, this is what it did. This is what your front system will play. Okay, almost no dips and nothing, despite my miserable sub and unmatched sub and large front speakers, one of which has no bass response below 50 Hz because of wall reflections, and boosting all the other speakers. And this is the MIMO filter if you want to see what it looks like. So that's that. Okay, give it a listen. It is my experience, okay, because I have only one miserable sub and near the front speakers, and my front speakers bass are stronger than the subwoofer itself. It is not really functioning fully. I also didn't have the time to try every combination, but in my experience, it definitely sounds different. Like it's like the bass is wrapping you wrapping you around you. This is, I think, the only description I can come up with. But is it like a better bass? I'm not sure. I mean, at least in my setup, I prefer good old style with a properly time-aligned and EQ'd bass. And I want to see my FL and FR individually sounding at the target. I mean, here, the reason you only see this one is because if you measure FL or FR or the sub individually, you will see quite a horrible response. Only when they play together, they give this output, okay? And it's the same with dirac, but dirac, obviously, they cheat. When you measure FL in your dirac system, secretly, all the other speakers in the room, they play, because art is on and engaged, and you get this flat response. But there is no way to measure a single speaker like this in my model, but I can measure like this. Measurement is off, of course, but there is L plus R measurement in REW, and when the mode is LFE plus main and audyssey flat is engaged, you will also get this response, which is what you're going to be hearing where you're sitting anyway, okay? You don't necessarily hear separate sounds from the left and the right speaker. They almost always come from both. So give it a try. Especially I am thinking with asymmetric systems, with problematic systems which have very high asymmetry in the fronts, okay, and some systems with lots of subwoofers in different parts of the room, or some systems with different subwoofer models, which is normally not a good thing, might just miraculously benefit a lot from this. We will see, you know, it's just, I'm releasing it today and a lot of people will try. We'll see how the feedback is, but it is different than double bass, and it's different than every other bass I have heard from my system. And it's not only the speaker limit, it's also audyssey converts the filters to minimum phase. I mean, the trick is about stealing phase from the other speaker if its phase response is better than yours. And the code is doing this, okay? The algorithm is very sophisticated, but at the end, just before they go to this receiver, they are converted to minimum phase. So it is still some phase that needs to be applied, but it cannot apply all of it. It can apply the minimum it can, but at least at the right direction. And there is more I can tell you about MIMO, but not before. Okay, now I will close this because reload may give bad results now. Too many changes happen, so let's start again. Go to my measurement again. Low volume listening compensation, this is the default of Express, and this is like dynamic volume default for -20 dB. But now you can change its high frequency, how much it's gonna boost, and here are the explanations anyway. Read all of these very carefully, okay, before you play with them. And here's the bass boost. So if the bass is too strong for you in low volumes, you can lower it, and if your treble is not high enough for you, you can increase this one. Be careful with treble boosting. If you're listening at very high volumes, this is the one that can damage a speaker, nothing else. You can do this and turn it to 100 decibel and subwoofer will survive, although it will clip like crazy or distort, but this one burns the tweeter, because tweeters get hot. 2.4 default by the dynamic volume curve itself. But now that it's adjustable, you have no excuse to not like low volume filters, because they will definitely, there is an adjustment here that will definitely sound as good as when the volume was higher, or you just cannot hear good enough in low volumes. Okay, there's no other explanation. I'm kind of like that, by the way. What else? Allow manual time alignment. This is quite an advanced one, okay, but very useful. If you have, for example, Dolby enabled up-firing speakers. When code pulse here, by the way, here you can, these are linked to the video tutorial, this one, so you can always, for people who just download and start watching, start using this tool, they can click these links and they can listen to this explanation and suffer my accent, but there is no other way. You go to impulse window, you can't do anything with subwoofers, but the speakers, you can double check if they are properly aligned on each other. I mean, AcoustiX never gets this wrong, okay? And this new version actually aligns samples. These are the, when you zoom in, you see the samples. This is the actual samples before the FFT is done, okay? And the samples are all at the same level, which changes the tips because of the interpolation errors of REW, but samples are identical. And it will get even Dolby enabled speakers correctly most of the time. But if you have a very problematic speaker, I'm again repeating, subwoofer should not be here, but everything else. If you don't see this, for example, let's say your FR was off like this. Let me show you what happens with Dolby enabled. I lost. Or with an inverted speaker, for example, what happens? That is easier. This is gonna be how it will be aligned. Okay, I can do a lot of things now, but it's not gonna be a tutorial if I do this. So let's say you found it like that and your FR is misaligned because it was inverted. Okay, then right click on that speaker, go to offset T equals 0, click it, and this is the slider. This is fine adjustment. Even fine is not too fine, and you will never need this one. It will just fly it all the way to the other side of the screen. Reset. But the good thing is you can click on that and then use keyboard cursors like that. This is less. Also, you can key in the values and you can key in a lot more accurate numbers here in case. What happens is with Dolby enabled speakers, okay, this is the peak, but there is the first peak somewhere here, and then the reflection peak from the ceiling. And the reflection peak should be aligned to front left speaker. But many systems, even this one sometimes might do it, will align this first small peak here. That peak will be shorter than the inversion peak if your Dolby enabled speakers are proper, because they are designed to really reflect to the ceiling a higher impulse than they reflect to the front. And here you can come and align them, and I think this will be a breakthrough in Dolby enabled up-firing speaker alignment, because I can assure you dirac will never get it right, okay? And I can assure you Express gets it wrong at least 30% of the time if you have Dolby enabled speakers. This is your opportunity to fix that. And also, some very weird systems can, I haven't tested yet with AcoustiX, and I changed the time alignment algorithm. It's even smarter now, but it's always possible if you have a very weird system, and it's good to come here and check at least once if this alignment is being properly done. And wherever you decide it's the correct alignment, you apply and close, okay? And close it and continue. And now I changed the FR distance quite a bit, as you see. And on the importance of that, by the way, let me wait for it to finish and some more things there. Don't get too obsessed on the impulse peaks or like sample alignment like I do. The distance alignment is accurate to only 3 centimeters and even longer, 3.4 in the new models. So the minimum that it can delay a speaker different to another is 3.4 centimeters. So when you check the differences here, how we messed up. I deliberately messed up FR, okay? And look how much difference right now. 0.028 meters, which is 2.8 centimeters. So it's still less than what the AVR can do. So for the AVR, these two are on top of each other. And 3 centimeters is far shorter than the distance between your ears. So you do not have to really obsess on this one too much. But with Dolby enabled, really, you will see that depending on your ceiling height, it's somewhere like here, which is about 36 centimeters difference. It will make a lot of difference in Atmos immersion. By the way, when you have Dolby enabled speakers, the measurement tool, this screen will remind you to correctly set your ceiling height before taking measurements. Okay, and listen to that advice. If you change it after the measurements, you will ruin this alignment one more time. So now rerun. What else do we have? Enough customization? Guys, actually, let's go multiples. Let's do a 4-sub optimization. I need to hack the receiver config file. Replace. See, now my original configuration is gone again. I can't show you transferred filters, but that's fine. I can show you in some other way. Now again, optimize measurement, and okay, we need 4-sub measurement here first, which is here. that the correct one? That seems to be the correct one, yes. So now this also in here, but now I think we have to get out. Oh no, it found it already. So 4 subs. Started. So this nice little hack, let's customize. Volume alignment, manual time alignment. Do you need to see that again? No, it's very cumbersome. But and add custom filters. And no need. Start optimization. I'm not even sure if this measurement and this configuration are the same files. So now with multiple subs, it stops again after aligning all the speakers, and you have target and the subs. First you align the target as you wish. I mean, I'm just randomly moving it to show you how to use the tool, so I'm not really thinking this should be the target level. And then you can align every single subwoofer before they are aligned with each other. See, this is subwoofer 1. It could be more useful that way. And then subwoofer 2. So if you think you know it better, but here there is a problem. The subwoofer levels are not coming correctly. Like, this is not what optimization should have done with them. I should check this before I upload the release version. So subwoofer 3, yeah, it's definitely not working, but you just had to, you can actually align every single sub to the target as you think is fit. This is gonna stop after automated alignment, so they will be at better levels than this one. Actually better levels than you should change, but whatever. Cancel reverts everything back, and confirm goes and starts. And with this horrible subwoofer leveling, by the way, I don't expect any nice results at this point. And here it is aligning 4 subs between each other by using about 1 billion loops, but with a very clever technique so that it can finish it so quickly. And now this is the combination subwoofer it came up with, and here it gives you another opportunity to align its level. Probably something like this. This guy could be a good candidate for MIMO filtering because he has 2 subs. Look at the distances, and all of them inverted. But this is because of the volume level problem. I know how to fix it. Anyway, sorry that in the video I couldn't demonstrate this to you properly, but it's a very quick fix, in fact. Okay, let me show you add custom filters. Again, use REW EQ to add your own custom filters to any speaker sub. All will be added reference mode to the original filters flat mode. So when you use custom filters, you lose low volume level filters. First, flat will be the optimized calibration, and reference will be your custom filter calibration. So you can quickly compare even if you don't have presets. And if you have presets and you insist that you want low volume level filters, then you will need to swap them in the JSON file, which is very easy actually to do with the script. And look at the final level, by the way, looks beautiful. Anyway, Now, these are the results, and as you can see, if TFL final, well, this is not that bad looking. It's a purple one, this one, right? Yeah, this one. Look at this peak here. Horrible. Okay, dirac does it so much better. So you go to EQ on, like, let me show again. This speaker, this is the final result of the speaker. So you go to TRR final, right click and EQ. And here the target level and the target curve comes already adjusted. Like it's this level here will be inside the final EQ window. And here your options are, for example, you want to do full range EQ because you know DSP so well. So what should we do? 20,000. Okay, let's be a little bit less. Low shelf, half shelf, whatever. You can just match response to target in whatever smoothing you want. Let's go psychoacoustic. No, let's do even a better calibration, like full EQ. See, this is such a good DSP now. It made it look. Look at the result. Perfect. Acoustics could never do it that good. You don't have to generate or anything, and you can generate if you want to see what they look like, but you don't have to. What you generated should be here. This is what you generated. Look, beautiful, 20,000 K filters. But you don't need this, so I'm removing this. And then let's say you decided you can do C filter. Okay, this is really the necessary one, so I'll be serious. For example, if you can't hear C speaker nicely, you can come to EQ filters and add a. Okay, let's do it this way. What's here? 200 to 200. Let's keep wherever I was smoothing, but let's window the response. C final with this one. Show you all the screens together. So this is the IR windowing. You can change even these numbers to apply a time window, or add frequency dependent windowing, or add multi-time windowing. As you see, multi-time windowing automatically make the speaker just like the target curve. So there was actually no excess or boost in the speaker. So if you really EQ'd them, you would kill that speaker. But anyway, let's suppose, but these are everything you can actually, a lot of people kept asking different target curves for different speakers. Here you can change your target curve to whatever you want for the speaker. And the target level too. And use Red's auto EQ, for example, like this, up to 200, let's say. Why? Refuses to EQ it. Let's do it 12 dB boost. Yeah, there you go. Now this is perfect calibration. Okay, so you do this part with REW auto EQ in any smoothing or time windowing you want, and then here at 328 Hertz, you want to cut that peak. Create a notch filter. 328 Hertz. What's the result? Well, it only got. How about this one? How about this one? Did it die? No, too tough for notch filter. We have to go with peaking filter. 328. This is gonna be like 225 or something, and -5. What happened? 25 was too much. 10. Why is this filter not? Yeah, something like that. And then turns out even 10 is too much. 7. Yeah, and minus. Well, the predicted used to be different color in REW. Now they come in the same colors, which is a bit confusing if you ask my idea. But I can still see it. I hope you can too. Look at the predicted now. So that peak is gone. So you can add your custom filters, whatever. You can use REW auto EQ filters. You can disable any one of them. Okay, whatever is here, all 20 of them, even the crossover filters, if you really want to fancy even further, will go to your AVR as additional filters on the optimized response. And this includes, for example, well, with C speakers, for instance, this is how you delete all the filters. With C speaker, this could be useful for speech intelligibility. For example, a peaking filter at 2500 Hertz. I mean, some people have mastered this filter. I didn't really. I don't even have a Setner speaker, but it should be something like that. These will start going around very soon, I believe. One at 2500, 6 dB boost, and one at 5000 Hertz with 3 dB boost, again Q5. So these two filters, boosting these two frequencies, increases the intelligibility of conversation, dialogue. So this is like a dialogue enhancer. So it doesn't have a dialogue enhancer like Acoustica because it has anything you can imagine. Up until it becomes intelligible for your ears, you can play around with this. And this is going to go to C. And again, you can open this window in EQ and go to phase so that you can see it live, and add an all-pass filter, for example, which is a filter that only changes phase and not the frequency response. So nothing will change here, but you can change here. And let's say you want to bring this to 0 degrees. So 65 Hertz. I'm doing totally random corrections, by the way. Okay, let's keep going up. You want to bring the phase of C speaker at around 65 Hertz to 0, so there are no phase shifts at that frequency. The problem is the all-pass direction is wrong. So they all rotate this way, and all-pass rotates even more this way. Time-inverted all-pass would rotate it backwards, which we can't do with this interface. And it's not like you can invert every phase. It's impossible. You can only invert about 4.5 milliseconds of phase at most. Beyond that, it will be unlistenable. You cannot move walls in your room unless you have dirac art. So something like that, if in my view, if you will ever add all-pass, add it at the crossover voice location, right at the crossover frequency, and always use 0.71. This is square root of 2 divided by 2. And it's not a random number, it's what analog crossover filters are designed to yield, the Q value of. I mean, square root of 2 is very frequently used in DSP. And 0.5 also is a useful number, and don't go too low. I mean, if you make this 0, you're going to flatten the phase, but that filter will, I mean, I don't know. It's not going to work as what 0 means. You apply all through the frequency band, you try to invert all the phase. It's not possible. It's not going to sound good. So the graphs don't always show you what you will hear. So let's say you decided this speech enhancer, dialogue enhancer, and an all-pass to C, and you're done. Maybe to subwoofer also. Go to subwoofer file. So with MIMO, what I was going to say, if you have MIMO engaged, then you cannot customize front left, front right, and subwoofer. Okay? Keep that in mind. And what should we do to subwoofer? Oh, of course, there's a dip here, which acoustics could not fix. Stupid acoustics. What should we do? Of course, boost it. And of course, high shelf will be great. Match. Perfect. Look at the bass response. Never seen something like that. So you did all this, you're done, you feel you're done. As I said, you can apply from here to each and every speaker and sub forward frequency dependent windowing. You can change the window sizes here, which are useful for some things. You know only if you know. I'm not going to go into all these details in this video. I mean, Express users should already have been very alienated with all that. You don't need any of this. In fact, it's time to talk about it, right? I mean, let's be clear, customization wasn't added because Express needed improvements. Express mode is already a proven solution that delivers exceptional results out of the box. No DSP background required. Many users report it's the best their system has ever sounded. The AcoustiX Express version is even more refined, better target curve, improved speaker time alignment, and subwoofer volume leveling. The real motivation with customization was to serve advanced users who want direct, transparent control at their sonic stamp and test new ideas. I mean, this is an unprecedented level of customization now with every REW filter type stackable and assignable to any channel. You can effectively redesign your entire DSP chain from the ground up. This isn't about complexity for its own sake, it's about giving experienced modders the tools they expect and respect. More importantly, this is a legitimate learning environment. You can deploy a filter, audition the change instantly, compare outcomes, and build actual DSP literacy through practice. And if the community identifies a pattern, some custom approach that consistently improves results, that becomes data for future automation. I mean, after decades in this field, in an obsessive compulsive fashion, I'm still learning, and community-driven discovery is how the platform will evolve. That's fundamentally different, by the way, from the noise coming from self-proclaimed experts who critique without having examined a single line of the core algorithm, nor that they will understand. There's a line between constructive feedback and uninformed attacks. Be cautious of anyone promising better sound whose credibility rests on disparaging existing work rather than demonstrating their own. The approach reveals more about motive than expertise. Finally, this level of customization will naturally debunk common misconceptions. Some users obsess over perfectly flat, full-range graphs or aggressive EQ above the Schroeder's frequency because it looks correct on paper. Now, they can test these theories directly. When you hear the actual outcome, the gap between measurement and perception becomes self-evident, and that's where real understanding begins. And now that we have all the custom filters, like in every final response, everything that is in the EQ filters will go to the speakers. You can change your targets, levels, add any filter, disable any filter. I mean, there are some filters already applied that give this final result. For example, this FL filter here, but it's quite easy to reverse that because obviously some people will hate everything acoustics and revert them first because they know better. Anyway, the cancel here will not cancel anything. The filters will go through, I think. Well, what I know is that the moment you select custom filters, what I remember, low volume filters are gone. I mean, even if you cancel and the filters don't go through, you will have identical flat and reference modes. So confirm, and it continues, and done. Your MIMO is only with XT32, by the way. Due to its below 90 Hertz nature, obviously, XT also cannot do it. It would be a MIMO between 90 and 120, and below 90 it would be just a sub. So it's if MIMO really picks up, everybody loves it, then I can try at least implementing it for XT, but at the moment it doesn't make sense. What else? Any other customization left? Let me try to hack a bus shaker, but I get different receiver config files which totally mess things up. So let's see what we have got here. When you have more than one sub during the measurement or configuration, because my AVR has only one sub. Okay, I can do this actually. Okay, let's change it to 2 subs, give it a try. And it did. Now, because I made a change in my system, I'm gonna go say replace AVR configuration. Because last configuration was with 1 sub. And see, it has 2 subs, as you see here, and yes, continue. So when you have two subs, as you see, it's asking me, I see two active subwoofer outputs. Is one of them a bus shaker? Now I will say yes. The system will assume the highest numbered subwoofer output is the shaker and exclude it from acoustic measurements. AVR discovery complete. So now it produced a receiver configuration file. Should be a new one around here, yeah. Like this one. With two subs and has bus shaker true. Okay? You don't do anything manually, it's all automatic. And when you now go express calibration or measure your system, it will only measure subwoofer 1. Because it knows subwoofer 2 is a bus shaker. And once you have a measurement, I'm no longer encrypting the measurements, so you can use your... I think at this stage, we are gonna be able to use bus shaker customization without a problem. Try to select this one. And now as you see, bus shaker option is on. And here you can select any curve you want, or also your custom curves, and you will see the shape of those curves here also. This goes only up to 250 Hz because it's bus shaker. You can adjust its gain, which you can also do in the AVR. Invert polarity of the bus shaker, which could be interesting. I mean, I have no experience with a bus shaker, but inverting polarity of something that produces bass might always give different and better results. And more importantly, when you start optimization, it stops here. After calculating all your delays and subwoofer optimization and whatnot, your actual limits, depending on your model and your other speakers and their distances and the subwoofer alignment, the TR delay. You can go up to 10 meters or to minus 0.72. This is your limits, legal limits from the setup and the hardware coming from. And here you can say change them by 0.1 meter distance. If you go to minus values, it will have to shift all the other speakers, but it's still okay and it's identical. So you can adjust your TR timing. By the way, this side here, and always read all these explanations, especially initially. I'm not talking on each and every one of them because I already wrote them down for people who don't watch the tutorial, at least. But I think timing of TR is one of the most important things, and here you can just change it, and this means it is gonna fire earlier than anything else, and this means it's gonna fire the last. So you have an idea what you think. And the initial level that it shows up is your SW1 delay. Same, this, if you don't do anything, it's gonna get the same distance as SW1, okay? I hope these are good settings for TR owners. I have no idea. I'm sure in time we can quickly develop this further if it's necessary, but I think by inversion, custom filters and custom time delays and gain, which you could do in your AVR, but still it's there. There is nothing you cannot adjust with your TR. You do not need to, or maybe you shouldn't even set your last subwoofer as TR in the menu, because I know new models have it, because I think it will disable all this. Just use it as a subwoofer. The code is smart enough to understand, and it's not going to measure it. You can keep it connected and on during measurement stage. Also works for fixed day. Obviously, this is also XT32 because you need at least 2 independent subwoofer lines, which XT and below don't have. Confirm, and here NTR is added, as you see, with 8.39 meters, whereas sub is 6.63. Done, and now let's see the filters. Reload, choose file. That's the correct one, and import. Yeah, So this is your OCFI filters. Low volume filters, edit, FR, LV, like high frequency edit, and to the subwoofer, also bass edit, and look at SW3, this is SW1, and SW1 low volume with bass edit to the sub, and SW2, and this is your TR filter that was in the graph, as you see, boosting below 20 Hertz, and this is TR LV, it's the same. I couldn't risk adding low volume boost to TR filter. Okay, I mean, but subwoofers, the other subwoofers gets it. What else? Don't forget to, yeah, any hardware change, like you remove your TR or you add another sub or you change your speakers, always use this one, replace AVR configuration before doing anything else. I think I explained everything about the program. If you want to learn more about REW, how to use it, John's tutorial itself is excellent. Everybody who's interested in DSP should read through at least the parts that they are interested in, because it also has explanations on the oscilloscope facility in REW. But to be honest, this is how I started learning DSP, from John's manual. Express was shifting 40 Hz crossovers to 60 Hz unless your speakers are really going deep down, which it shouldn't, but nobody likes 40 Hz. This one doesn't. It will set the crossover to whatever it thinks is correct. And if you really don't want your 40 Hz, you have to go to custom. With your Express measurements, you can and shift that one to 60, and then it will never be 40. It's that easy now. And there is a support project button. I have to explain this because it goes to my Revolut page, and here you can make a donation. I had to say this because some people really use this for donation from Acoustica, but unless you write a note, Revolut doesn't tell me who sent the money. Okay, anything, no information, not even the country it came from. So if I didn't thank you, some people thought about writing the note, like who they were. Then of course I thanked them, but I'm taking this opportunity to thank all those people who sent me money through Revolut. The reason I didn't thank you is because I didn't know who you are, just so you know, unless you write a note here. And enjoy your system's full potential. I think I'm done. I'm sorry if I forget to explain anything else. This video is so long now that it will take years for me to edit it and post, but it will be tonight. And remember, if your system has basic setup issues, no secret magic curve is going to solve them. Sometimes the real fix is the extremely powerful technology called moving the subwoofer 30 centimeters.